Hey, I got a little story to tell you about one that I ran into a few years back over there. There was this Laredo that basically was a one of them 4x4s. It was an older one by today's standards, and it was a '96 model, 87,000 miles on it. The check engine light was on, and somebody had replaced both of the oxygen sensors. Now, I don't know how many times you've seen people throw oxygen sensors at one, just hoping that would take care of it. And for a long time, oxygen sensors were a lot like a spark plug. It seemed like it would make sense if you just go ahead and change it if you were having some kind of problem that might be fuel related, because there's different kinds of fuel injection. There's speed density and there's density speed. Just for a couple of the primary ones that was around for a long time. The speed density systems. Well, there's also mass airflow. That's the other one. The mass airflow one is looking at how much air is coming in. That's the primary input. The speed density system is basically looking primarily at the engine speed and also the density of the air in the manifold. It uses a map sensor. The density speed system also uses a map sensor, but it's all about the priority of those inputs from what I've been able to tell. Sometimes they'll just give you information, and some of the research that I've done on some different systems and all nowadays when I'm writing for these training companies, you can dig and hunt and poke around and try to figure out what they mean by a particular term they're using, and sometimes it's difficult to figure it out unless you were happening to talk to somebody that was a trainer and all that at a place. Now, as far as oxygen sensors go, when I worked at the Ford dealer and we did all of the work for the phone company on their vehicles, they had these little Chrysler K cars with the carburetors on them. You might remember those silly things. And those K cars would have an issue that they would develop where they would idle rough and try to stumble and almost stall when the air conditioner kicked on. And we worked on those things, we were blue in the face. Now, I was at the Ford dealer, we had no books, we had no nothing. Scan tool wasn't a thing on those K cars, really. You basically might be able to get some flash out codes, but that didn't do you a lot of good on those. But what I finally figured out was that if I was monitoring the oxygen sensor voltage when that thing pulled that stunt, then the oxygen sensor voltage would drop away to almost nothing, and then it would come back. To go lean, it would stay there longer than it should. And these were one-wire oxygen sensors too, because they had a ground coming through exhaust. Well, I found out if I got a little bit of carburetor spray, and the moment this happened, if I could right there at the base of the carburetor just mist a very small, from through the tube at the base of that carburetor gasket, it seemed to make a difference. And I said, well, there's something going on at the base of this carburetor. After I'd fought with these things for months, trying to figure out why so many of them were doing this, they all had the same problem, I found out. I took the carburetor off and I got the gas all out of it, because you don't want to take a carburetor and turn it upside down because it gets trash all up in there, and then you got one that won't hardly run and it doesn't idle good and all that. But I blew all the gas out of it and cleaned it out really good, make sure it was good and dry in there. And I flipped that carburetor over and I put it in a vise, and the carburetor was long and skinny. The bottom of it was. It had holes in each part, but it must have been probably 2.5 inches at its narrowest place and about 5 inches or 6 this way. And I started very carefully flat filing the bottom of that carburetor, and I saw it got shiny on the ends first, which meant that thing had an almost imperceptible bow in the bottom of the carburetor. It looked like it was sealing okay when it was torqued down. When I flat filed that doggone thing, and I cleared up, that little bit of an air leak that you couldn't hardly detect, all of the problems with those air conditioners kicking on went away. And also, there's another thing. If you had the EGR tube, sometimes you'd have to flat file that, but most of the time, flat filing the carburetor to fix it. I fixed just about every doggone one of those things that we were working on, because there was a fleet of them that the phone company had, GTE. Anyway, we got that was a victory, but it was one I fought with a long time before I figured it out. And those little cars were very annoying. I don't know if it's true or not, but I had heard somebody say those cars were originally designed and created by Chrysler to be marketed by Kmart, but I don't even know if that's the truth or not, so don't quote me on that. Anyway, this one here, a fresh perspective on a tough problem can be instructive even if the guy that's offering the perspective is not a rocket scientist. You know, I wasn't a rocket scientist. The other guy had been working on it. It was beating him up. He couldn't figure out what was going on, and we were just trying to work on this together. You know, sometimes when I run into something I'm fighting with, I'll run it past my friend Donnie over there. When he and I start talking about it together, light bulbs come on, and sometimes he'll call me about a problem he's having and stuff like that. Well, until '91, Jeeps had no malfunction indicator light. How they got away with it's beyond me because it was law before that. But when Chrysler acquired Jeep and started building Jeeps, it didn't take long for the old Bendix Bream box to find itself discarded in favor of a Chrysler S-Back, which was a single board engine controller. And from that point on, Jeeps had a mill light like just about everybody else. It happened in '91. And from '87 until '90, the old Bendix system prevailed on those vehicles, and it was a strange bird. If you had never run into one of those, it didn't have a conventional scan tool port. You had to have an adapter for your DRB2 to read codes from that thing. The little connectors were over there on one side under the engine compartment, and it was something they had inherited from Renault, if you want to call it that way, whenever they inherited that from. And Jeeps were outfitted with the same thing that Renault was. In the old MS 1700 tester, if any of you have never seen one of those, you haven't missed anything. I used one for years, and it was a drag. But anyway, fortunately, the '91 models had something you could do. You could look at. But here's the thing. The oxygen sensors on the 4-liter, and incidentally, when Jeep first started having that 4-liter, it was built at the John Deere tractor plant, the engine, the hard part of the engine was. I mean, the Bendix system used a weird oxygen sensor, a Titania Zero, that operated in a 0 to 5 volt, this is an actual pattern from it, range with 5 volts indicating a lean exhaust and 0 volts indicating a rich exhaust. Was totally backwards. When I was working on a Jeep, I had to think a totally different way than when I was working on anything else. But the '91 model didn't do that. The '91 reverted to what it was, what we were accustomed to. But those are strange too. They've got stuff going on there. All right. This sensor though on the old ones, '87 to '90, used a 5-volt feed at all times. It had the equivalent of an internal thermistor. It reacted to the temperature of the exhaust. A rich exhaust is cool and a lean exhaust is hot. And these sensors weren't quite as reliable as the ceramic zirconia sensors used by most other manufacturers. Now, it's kind of odd. Whenever Thunderbirds, in the mid-90s, Thunderbirds started putting titanium sensors on some of their cars. Didn't take long for them to trash those and have us put regular sensors on there. But those were still reading 0 to 1 volts in those days. Okay, so the '96 OBD2 controller sends 5 volts to the sensor like the old Bendix unit, but for a different reason. It operates the 0 to 1 voltage range when it's working. When it's first started, if you happen to be looking at the scan tool values on the DRB3, you'll see a voltage right at or just below 5 volts. Alright, so the internal heater heats up, it actually drops down into the 0 to 1 volt range, and then it starts paying attention to it. Closes the feedback fuel loop, and it starts operating on closed loop strategy. One of the things that oxygen sensor heaters are tested by some of these Jeep and Chrysler platforms in certain years. When you're parked and you're in the house at night, this thing turns on that oxygen sensor heater and watches it to make sure those are okay. So it's doing it while you're sleeping and you haven't driven it for a while after it's cooled off. That's sort of an interesting thing. I learned that at Chrysler School, by the way. I don't know if you can read it in a book anywhere. Well, if the sensor doesn't heat up, the voltage stays high. The PCM stays in open loop. Here's your loops here. You got your controller, actuator, process, sensor, and then it goes back. See, I'm making a full loop right there. If the sensor wire has been disconnected or cut somehow, the voltage stays at or near 5 volts, and the PCM remains in open loop. It just goes by everything else that it needs to use to make the engine run right, but it's not keeping it perfectly balanced like it's supposed to for the stoichiometry aspect of things. All right. Ryan drew this '96 Grand Cherokee. The DRB scan tool is big on verbally defining the codes it spits out, and in this case, it tossed an O2 sensor shorted to voltage code. Well, that's a strange thing. We pulled up the scan tool PIDs for the front and rear oxygen sensors, and this is kind of what we saw. Notice that, 4.9, 4.65. All right. Now, using wire colors from the schematic, he had gone through a wire-by-wire check of the harness and found all the wires had continuity from the PCM to the oxygen sensor. So it wasn't long after that I showed up, so he called me over. The shortage of voltage message wouldn't go away, and he had even tried to substitute PCMs. We didn't have to program those in those days. I mean, you could flash them, but you could do an ABA swap. Now, on global architecture vehicles nowadays, since about 2010, General Motors has got a lot of global architecture situation going on that even if you've got a car exactly like another car, you can't swap controllers from car to car, because there's some identifiers there that won't let you do that, and you can actually cause yourself some big trouble. Ford has that too. They just don't call it global architecture. So be very, very careful about swapping modules from car to car. Alright, so I looked at the connector. I noticed one of the metal terminals was visible. It was pulled out of the rear of the harness connector like it had been pushed back, wasn't making contact with its mate in the other part of the shell. Somebody had been fooling with this. I don't know why, but they had. Alright, so we walked over to the Mopar diagnostic system and pulled up the pinout. Alright, the pinout looked like this on the MDS. And the MDS was vaguely similar to Ford's SBDS, but it wasn't as good. But you basically would use your DRB3 when you were doing flash programming. There was a phone line connected to the MDS unit back in those days. It was before high-speed internet. And you would basically, whenever you plugged your DRB3 into the vehicle, there was a cable that you would bridge the MDS machine to the vehicle with a long cord. And if you needed to flash something, you would tell, it would pull up and it'd say, hey, there's a flash on this, do you need to do this flash? Or whenever you do a search for a particular symptom or whatever, it would give you that. So one of the things that I did one time on a Dodge truck, they were trying to sell, and the guy wouldn't buy it unless they got this transmission problem straightened out. I may have mentioned this before. If I did, forgive me, and you can just hear it again. But he said, I'll buy this truck if you can get this transmission straightened out, because it was hunting in and out of fourth gear. And so I hooked up the Mopar diagnostic system through the scan tool to it, and they told me initially to put they had taken it to a transmission shop because we were swamped in the shop back there. Transmission shop says, well, put a throttle position sensor on it. If I don't do it, we'll have to rebuild the transmission. So they gave it to me, told me to put a throttle position sensor on it. They didn't even let me do a diagnosis on it. And so I said, I don't think I'm going to just plug MDS into this thing and see what I see. So I plugged it in. There was a bulletin on that and a reflash. And they said that you could fix one that was hunting in and out of fourth gear by doing a reflash. And so I selected that reflash, and I did the reflash. They drove the truck. The hunting in and out of fourth gear was gone. The guy bought the truck, and they brought me a gift certificate from the steakhouse to get me a steak dinner. But anyway, they made the sale because of that. A lot of the times it's a good idea to look at that. But anyway, we pulled up the Mopar diagnostic system. This gives us wire colors, and this gives us the pin numbers in the upstream heated oxygen sensor. Automatic shutdown, that's the relay that powers up your injectors, your alternator field, and it's vaguely similar to the EEC power relay on a Ford, but it goes beyond that because it also fires up the ignition coil. And on a Ford, the ignition coil is powered up through the ignition switch. So it's similar but not quite the same. But it's typically on the ones that I was working on back then, it would be a green wire with an orange stripe, and it came from that one relay. It also sent a feedback to the engine controller. Alright, so the pinout schematics can be confusing at best. Sometimes you don't know. What I always like to know, am I looking into the connector face? Or am I looking into the harness or the component? You can just get really turned around. If you've done a lot of wiring schematic pinout stuff, you got to have it firmly in your mind what it is I'm looking at and which shape code is which. Does this plug into there, or what's the deal on that? And so, you can really get bogged down on that and compare that to the real world. So this connector is so easy to disassemble, it makes it more likely to become the victim of an overzealous owner. When you take this thing apart, those pins are just there. If you make a wrong move, suddenly the pins are waggling in your hand without being in the connector. You don't know how to put them back in there, or don't have a good way to guide yourself. You can really get in some serious trouble, and that's what had happened to this guy. Okay, somebody, I don't know who it was, all right, assuming the schematic to represent the harness connector and not the oxygen sensor connector, Ron had peered into the connector, lined up the shape codes with the illustration, and checked the wire colors, and it looked like they were inserted correctly. I believe he did the same thing that the original person did. I don't know if that guy had a pinout, but the fact that he's felt like they were all lined up like they were supposed to based on the pinout and the way he was interpreting it would indicate to me that the first, whoever worked on it to start with, had done that same thing. We realized that some numbers on the back of the oxygen sensor connector were easier to follow. Some of you guys have probably already been talking about this. All right, now, the dark green orange wire is a 12-volt feed from the automatic shutdown. The purpose of that particular 12-volt feed is to provide power to the sensor's internal heater. So the black tan wire comes from the powertrain control module, okay, and provides ground when the PCM decides to power up the heater and the sensor. The black orange and black light blue wires are sensor signal and sensor ground respectively. If you guys ever tested an oxygen sensor, you can take I got a piece of a catalytic converter that had an 18mm hole thread in there, and I cut it off, made a little shell sort of thing, and I would put that screw an oxygen sensor in and hook a voltmeter up to the two wires. The two wires that are the same color on an oxygen sensor are typically going to be the heater on a 4-wire sensor. The other two wires, the black one will be the signal, and the gray one will be the ground, sensor ground, on the ones that I've tested. Anyway, hook your meter up to it, or your scope, or whatever you want to do, and this gets you a bottle torch and start heating that sensor. In a minute, you'll see that thing start to react the way an oxygen sensor does. When you move the flame away from the sensor, the voltage will go down. When you put the flame on the sensor, the voltage will go up. Pretty cool to play around with that. I did it teaching a lot. Well, cavities and colors were wrong on this. You might notice this beautiful little thing right here. They've actually showing you which color is supposed to go in which cavity. All right, you might notice here what you got going on. This right here, this black tan wire. See that black tan wire? That's supposed to be in pin 2. Well, this is pin 2 way over here. Now I had a number because that fuzzy picture didn't work quite right like I wanted it to. All right, pin 1 is supposed to be dark green orange. All right, that one is supposed to be here. All right, and then your black light blue is in pin 2, and it's supposed to be in pin 3. You see this? You see the musical wire situation we got going on here? Musical cavities. All right, so 4 and 1, 3 and 2, they're just all screwed up. That's a big problem. So what we had to do to fix that, I actually got another oxygen sensor connector, and I did. I wrote them on there like that, So we sharpied the connector using the numbers on the back of it for reference, and that's the back of the sensor connector. Basically wrote the numbers on there just to make sure we didn't get it wrong. There's your 1, 2, 3, 4. All right, the two white wires on the sensor provide power and ground to the sensor heater, while the gray wire is sensor ground and black wire is sensor signal. All right, so you got to keep that in mind. If you're testing this thing, you may think black is ground, but it's not. Black on this, these old hard insulated wires that come right out of the sensor. Black is the signal, gray is going to be the signal ground, and then the two same colored wires. Sometimes they'll be brown, sometimes they'll be black, sometimes they'll be white, but the two that are the same color, they're not polarity sensitive on the sensors I've seen, but they'll typically be the heater. If you measure from between both of the wires that are the same color, you'll usually see about 6 ohms on a cold heater element. And the heater element's a little glow plug type thing right down the middle of the sensor too, on most of them. With the connector reassembled and plugged in, the DRB started reading at the familiar level on initial startup and moved to a closed loop range. Took care of the whole problem. And it's good to be a self-reliant mechanic. Burrow into a forest without seeing the trees. It's a good idea to find somebody with a fresh perspective. In the early part of this, you might have seen that slide where I was talking about the helicopter skid story. I had this guy that was working under me when I was working down in Texas. And we had a little Kubota tractor down there. Those Kubota tractors are really cool because they're like a miniature version of a real tractor, with all the little parts and all. Anyway, he was changing the oil on this Kubota tractor down. Our company had a helicopter division too, where we had like 36 helicopters that flew stuff back and forth with the oil rigs and all that nonsense. Anyway, some of the helicopter mechanics were trying to put a skid back on a helicopter, and they could not get those holes to line up. They were fighting with that thing, but they were too close to it. And the goofy guy I had down there changing the oil in the Kubota tractor looked over there and he saw him doing it, and he said, "Hey guys, I can help you with that if you want me to." And they looked at him like they thought he was sort of a nut. And he went over there, and he just had a good head on his shoulders. He wasn't a brilliant mechanic or anything. But he went over there and he said, watch this. And he raised up one side of the skid and he stuck a bolt through it. And then when he raised the other side of the skid up, all the holes lined up. And he made those guys look downright silly. The point is, they knew what they were doing, but they were too close to the problem. If you're standing off away from it, sometimes you can see it better than you can if you get too close to it. So sometimes you just need to back off and think about what's going on. Two heads are always better than one. That doesn't mean that you should ask for help every time you get a job. Have you ever worked with one of those people that every time you turn around they're needing help with something? I know stuff they could figure out by themselves. I didn't like to ask for help. Sometimes my own hurt. Sometimes it would be a good idea to ask for help, and I didn't want to because I wanted to be the guy that figured it out myself without help. Well, no man's an island. But on the other hand, I've actually seen other people that wouldn't even try to figure it out. When I was in my early 20s and I was working in that company down there I was just talking about, I would have guys in their 50s that were equipment mechanics that would come and ask me why an alternator wouldn't charge when they should have known how to check it. And I'd have to go out there and figure it out for them. Anyway, the long and short of it is, when we find ourselves choosing that path, we can be irritating to other mechanics. If you're a young guy, there's nothing wrong with asking for help occasionally, and some guys really enjoy helping you, but if you keep letting other people fight your battles for you, you're not going to get better at it. All right, don't be that guy. All right, Technician A says a running problem that occurs only after repair work is done must be related in some way to the repair work was done. Can I get a witness here? Technician B says disconnecting the battery will prevent engine controller damage while performing body repairs that involve electric welding. Okay, what do you think? Is this guy right? This is sometimes correct and sometimes it is not. Sometimes a problem that you would swear was caused by the guy that was working on it was not. I knew a lady that was having her transmission oil changed on a little 84 little Marquis. And the guy changing transmission fluid, he is a competent transmission mechanic. I was totally involved with this one. And she left the shop, she got up there at the next stoplight and all the transmission fluid left out of it. She barely made it back to the shop. And so I got that thing up on the lift and looked at it myself because I was told to do that by the shop foreman and the service manager. The guy that serviced the transmission did not touch those cooler lines because they were a long way from where he worked, but one of the cooler lines had split right there at its little, the little thing where you click it into the connector. It had split right there. He had nothing to do with that, but it looked for all the world like he had done it. So it's not always the mechanic's fault, but you got to go to it with an open mind and attack it just say, if this was my fault, I'm going to own up to it. Don't get, sometimes you get mad when somebody throws you a comeback ticket and just ticks you off and you're hoping it wasn't your fault. But if it is your fault, you need to admit it. That's just the way it is. Technician B says disconnecting the battery. That is not a good thing. If you leave the engine controller connected and you've got your welding lead clipped on one end of the truck and you're welding on the other end of the truck, and that electricity can find its way through that engine controller, you will fry that engine controller. So the only way you can be sure you're not going to have any issues other than clamping your ground right there by where you're welding, that's about the smartest way to do it, is to disconnect every controller on that vehicle. Disconnecting the battery ain't going to do a doggone thing. All right, so anyway, removing a spark plug wire with the engine running and allowing the spark to jump eliminates a misfire like that. If it's running bad, you pull the plug wire and it starts running better as soon as you start stretching the spark. All right? Okay, you're letting it jump to the head of the plug. That means the spark is stretched. That means the spark plug is fouled. If you do that, you're overcoming that fouled spark plug when you stretch that spark and it starts hitting on that cylinder. Now, if you pull it off and it starts running better, if it's got a distributor cap, you best be looking for a track in there because that's probably what's wrong with it. Technician A says a flooded engine won't start because the spark's traveling through the gasoline coating on the tip of the plug. That's true. Technician B says a diesel engine can be flooded to the point that it won't start. That's true too. A lot of people don't know that. Our shop foreman didn't know that at the Ford place. I got a Power Stroke diesel in there that I troubleshot for hard starting, and the fuel pressure, the pump in the middle of the valley, the little mechanical pump, it's supposed to put out 55 to 80 pounds, or 50 to 80 or whatever it was. It was putting out like 20 pounds of pressure. And so I said, well, this thing needs a fuel pump. Well, when the guy over there, he I had a lot of drivability work to do, and so he took it to one of the line mechanics, and they put that pump in there. And after that, I saw him spinning it over trying to start it, puffing all kind of white smoke out. And so he walks over and says, "What do you suppose wrong with that truck? It was starting before we put the fuel pump on it." I said, "It's probably flooded." He said, "No, you can't flood no diesel." So finally I went over and pulled both battery cables off both batteries and cleared all the crap out of the memory, because when I looked at the scan tool, the injector control pressure was going through the roof. I mean, to like 3,500 pounds. And it had learned to do that when it had low fuel pressure. See? Anyway, when we cleared all that out, it fired right up. So you can flood a diesel by putting too much fuel in there so that it cools down and absorbs all the heat out of the combustion chamber when it's trying to squeeze the air. Technician A says these readings are normal since the ETC is reading coolant, IET is reading ambient air, and the TOT is reading oil. But Technician B says the scan tool, if it's an aftermarket brand, should be properly calibrated. This is bogus nonsense right here. This one here, if the vehicle has been sitting there a long time, that reading is out of line and should be suspect. That's where you go with that. If it's been sitting a while, now this is only if it's been sitting long enough for the second law of thermodynamics to even the heat out on everything, and nothing's putting new heat in there. Technician receives a diagnostic trouble code that indicates an open throttle position sensor circuit. He clears the code, it returns immediately. What do? Do you replace the throttle position sensor? Do you check the PID data and compare it with real world data using a voltmeter? Ohm out the circuits between the PCM and the TP sensor? To be perfectly honest, what I usually did in a situation like this, I just threw a sensor at it. But the smart thing to do is to back probe that sensor with a voltmeter and work it through really slowly and see if you can get it to drop out. See what it is there. So anyway, everybody typically knows enough to know that you can have a wire circuit, like if your signal return circuit, which is sensor ground, is open, you're going to have a wide open, you're going to have a 5 volt signal on the signal wire and on the 5 volt wire. If the 5 volt wire is cut, you'll have nothing there. If the signal wire is cut, you'll have signal return and voltage reference in the sensor, but the signal won't be making it back to the engine controller. Let your conscience be your guide on that one, but work it out. That's a good idea. But it's a good idea to sweep it through slowly and see if it drops out too. You can do that with a meter or a scope. Technician A says while checking a nose start, he gets these readings. RPM 220, injector pulse width, no. Technician B sprays some carburetor cleaner into the throttle body while the engine is spinning. The engine starts and runs at a higher than normal idle, but when switched off, it won't restart without a shot of carb spray. If the throttle position sensor is reading close to wide open throttle because it's a bad sensor or whatever, it can cause the injectors to shut down because it'll put it in clear flood mode. Like if you max the fuel all the way to the floor, it shuts off the injectors. No start due to city spark plugs can be caused by this, or that, any of the above. Technician A says abnormal long fuel trim readings can be caused by a leaking seal on the oil filler cap. That's true. The PCV system will pull air in through a loose seal on the oil filler cap and screw up your fuel trims. If you don't believe that, watch your fuel trims on a scan tool, take the oil filler cap off on a mass airflow system, see what that does. Technician B says an incorrect mass airflow sensor reading can cause abnormal long fuel trim readings, but the mass airflow reading may appear to be normal. It doesn't have to be off, but just a little bit to throw those things out of line, and I've seen that too. Technician A says late valve timing can cause map sensor equipped vehicle to run rich. That's true. Technician B says installing an aggressively ground camshaft can cause a map sensor equipped vehicle to run rich. That's true too, because if you got a really strong, aggressively ground camshaft, you put a cam in it, idling, it's going to have low engine vacuum, and that's going to make it run rich if you're using a map sensor. If you've done that, you need to put a mass airflow kit on there if you want the thing to run right when it's idling. Driving down the road, a cammed up engine runs okay with a map sensor. Idling, it puffs black smoke. I've seen that. Technician A says the PCM controlled cooling fan system can be checked using a 50,000 ohm potentiometer. Technician B says some PCM controlled cooling fans won't operate unless the engine's running. This is true. Even if you're using that, unless the engine's running, like on some of these GM cars, it won't work. The PCM controlled cooling fan system, if you dial that thing into the point where the cooling fan should come on using your potentiometer, you can get it to come on. That's a brilliant way to test it because it costs almost nothing and you don't have to get the vehicle hot. I hope you guys enjoy this, and I hope I've managed to keep your attention for longer than 3 or 4 minutes in the first part of the video, because some people don't watch these things in 3 or 4 minutes and then they move on. But I hope you get something out of it. I hope it helps you. hopefully, if you're studying for an ASE test, it'll help you that way too. Y'all have a good day, and I appreciate you watching.